Everyone, that's the way of greeting from now on. If I'm not coughing, it means I'm not grinning, y'all. Okay, so we're doing 6.22 this time around, okay? Seems like we gotta read this one carefully. There are several techniques for implementing the square root method in the math class. One such technique is known as the Babylonian method. What the heck? Did I even pronounce that right? Anyways, let's continue. It approximates the square root of a number n by repeatedly performing a calculation using the following formula. Okay, so its next number is equal to last number plus n all over last number. Last guess, divide the whole thing by 2. When next guess and the last guess are almost identical, next guess is the approximated square root. The initial guess can be any positive value, for instance 1. Next guess and last guess is less than a very small number such as wait. If the difference between next guess and last guess is less than a very small number such as that one there, you can claim that next guess is approximately is the approximated square root of n. If not, next guess becomes last guess and the approximation process continues. Okay, implements the following method that returns the square root of a number. There was a lot of information to grasp. Okay, so in order to simplify things, I've already created I've already created this class called 6.22a. Remember one thing, folks, on this chapter, on chapter 6 method, I'm not concerned about how good the solution is. If you noticed, I'm no longer having student A, student B, and student C. Okay, I'm just writing a solution. The point here is you gotta grasp how methods work. Okay, so don't let that off your mind. Okay, so here's the deal. I'm retrieving user input, my n, and I will only work with n if n is positive. Otherwise, we know that we have an error. That's pretty much it that the main method does. Okay, now let's get on to our display square root method. Okay, I'll simply go if is input valid. What I'll then do, I'll pass n to my input, and if it is valid, I'll simply go system.out.print. I'll simply print square root of n is sqrt. Otherwise, let me just put that over there. Okay, otherwise we have an error. again, this is not the most effective and efficient way of doing this. I'm only trying to demonstrate how methods work here. That's all. Nothing more, nothing less. Oh, again, you might make an argument that I shouldn't have had this if else statement. What I should have done is to only on this method, what I should have done is to only call is input valid. And that is wrong, and the reason is, in fact, it's not wrong, but it is wrong in a way that it's bad practice, right? You shouldn't let your method rely on its caller. By that, you'll see in a moment what do I mean. You see, check out these two. The main method and the display square root method. You see, from the main method, we're invoking display square root. Oh, you know what? I'm not invoking display square root here. But the point is here, perhaps I included this method for the sake of flexibility, I guess. Okay. Here's my point. What I'm trying to say here is you should make, given two methods, method A and method B. Suppose that method B receives some arguments, right? What you want to do is to make sure that you validate those arguments on both methods. You don't want to only validate it on the first method, the one that calls the second method only, because that will be considered as bad practice for your I mean, now I'm getting distracted by these people grading me. Anyways, here's what I'm trying to say. Given two methods, method A and method B, and suppose that method A is passing arguments to method B, you make sure that you validate those methods on method B, where the implementation is actually done. Suppose the method B is computing the area of a triangle, or perhaps the area of a circle. What you wanna do is to make sure that you validate the radius on method B. But of course, you can also validate it on method A, and that is considered as good practice, okay, as opposed to only validating your radius from method A, okay, meaning that your method B will simply calculate the radius of meaning that method B will simply calculate a radius, an area of a circle, without actually doing the validation. Again, I'm emphasizing this. You gotta make sure that the method that is assigned a certain task is also responsible for validating its arguments, period. Okay, so what else do I want to do, or rather say, is input valid? I have let me read through the question first. How do we tell a method is valid? It's, again, I just wanna go is n greater than or equals to 0, I know this is perhaps a redundant method. Now I recall the reason why I decided to have this in the first place was to demonstrate the fact that you can have as many method as you want, okay, and you can call one method. I mean, you can call multiple methods from one method, okay, just like this one here. We've called square root, and we also called is invalid. That's the reason why I decided to have this method. Of course, we can get rid of it, okay, and only invoke square root only from display square root method, which is again redundant if you think about it. We can get rid of it and simply have this square root method in the main method, okay. We can get away by having those two methods only as well, okay. Enough of that. Now let's get to the core of this problem. Now I'll declare my last guess is equals to 1. We were told that we can initialize it. We were told that we can initialize this at whatever number we want. So it's gonna be last guess. Now I wanna have a while loop. Now we've got to think about the difference. Now I'll keep going as long as the difference between last guess and as long as the difference between last guess and next guess is less than greater than 0.0001. Why am I having a compile error here? Oops, let me try to wrap that. What the heck is going on? Can anyone tell me why the absolute value method doesn't work? Oh, the method int. Oh, that was so stupid of me. Okay. Now I will simply update my last guess. I'll update it to next guess, and then I will go next guess. Let me check out that formula again. In fact, you know what? Let me just copy and paste there and put it over there. Oh, I missed it too. I'm hoping we've got everything we want. Oh, lastly, I'm returning next guess. Oh, again, if you think I messed up somewhere, again, I'm telling you guys, these two methods are perhaps redundant. We only gonna lose them in case we wanna eliminate all of that and simply invoke display square root. I'll show it to you in a moment. What do I mean? Let's try square root of 4. That is close enough to 2. I'll consider our algorithm as a good, or rather properly working algorithm. Okay, now let's try something else. A huge number like 144, the answer should be close to 12. Oops, precisely 12. Okay, you know what? Again, the reason I just told you guys, if we want to, we can simply get rid of this and simply invoke that. That's the reason why I created those two methods. In case you want to have a init main method, you can simply do this as well. 169 should be close to 13. Exactly 13. Okay, it might not be as close to, or rather as accurate as we want it to be, perhaps if we use numbers that do not have square root, that do not have square root numbers as whole numbers. Okay, but I don't know, you can play around with this however you like. That should be it for me. I'm gone.